Okay, we are going to start question number 8. The equation of the curve is y is equal to x cube plus ax square plus bx plus 5. The curve has the stationary point at 1, 9. Find the value of constants a and b. Okay, we need to find the value of a and b. These are two constants. We need two equations so that we can solve them simultaneously and find the value of a and b. So first equation can be achieved by using the concept of stationary point. As we know that the curve has the stationary point 1, 9. So it means this curve is passing through this stationary point. So this stationary point will satisfy the curve equation. So first 1, 9 satisfy the curve equation. So we can say that y is equal to x cube plus ax square plus bx plus 5. And this curve is passing through this stationary point 1, 9. So this will satisfy the curve equation. So plugging this point in the curve equation, we will have y, this one is x and this one is y, and 1 cube plus a times 1 square plus b times 1 plus 5. So solving further, we will have 9 is equal to a plus b plus 6, and solving further, we will have a plus b is equal to 3. So this is the first equation. We need another equation so that we can find a and b. So second equation can be achieved by using another concept that the at stationary point derivative is 0. So at derivative at stationary point means 1, 9 is always 0. So first we find dy over dx. So dy over dx is equals to the derivative of the curve equation, which is derivative of x cube plus ax square plus bx plus 5 with respect to dx. And we know that derivative of x cube is 3x square, derivative of ax square is 2ax plus derivative of bx is b, and derivative of 5 is 0. So we have find out the derivative of the curve, which is 3x square plus 2ax plus b, and this derivative at the stationary point is 0. So we can say that dy over dx at 1, 9 is equal to 0. So it's mean 3x square plus 2ax plus b at 1, 9 is equal to 0. Okay, plugging x coordinate value 1 in this equation, we will have 3 times 1 plus 2a times 1 plus b is equals to 0. So we have 2a plus b equals to -3. So this is the equation 2. Now we have equation 1 and equation 2. We can achieve value of a, b by solving equation 1 and equation 2 simultaneously. So from equation 1, b is equals to 3 minus a. So plugging b value, which is 3 minus a, in equation 2, we will have plug b is equal to 3 minus a in equation 2. So we will have 2a plus b is equal to -3, which is equals to 2 times a plus b. B means 3 minus a equals to -3. And this one is equals to the 2a plus 3 minus a equals to -3. And a is equals to -3 minus 3 equals to -6. So a is equals to -6. We have calculated the value of a, which is -6. Now plugging this value of a in equation 1, we will have value of, so plug a is equal to -6 in equation 1. So equation 1 is a plus b is equal to 3, and here a is -6. So -6 plus b equals to 3. So b is equals to 9. So we have calculated the value of a and b. Let's move to the part B. Find the coordinates of the other stationary point. We know that to find the stationary point, we need dy over dx and equate it with 0. And using this equation, we can find the x coordinate. So we already have dy over dx from part A, which is 3x square plus 2ax plus b. And in this case, a is equals to -6 and b is equals to 9. So dy over dx is equals to the 3x square plus 2 times -6x plus b, which is 9, and this one is equal to 3x square minus 12x plus 9. We will equate dy over dx with 0 to find the stationary point. So 3x square minus 12x plus 9 equal to 0. Further solving, taking 3 common, we will have x square minus 4x plus 3 equal to 0, and we will have quadratic equation which is x square minus 4x plus 3 equals to 0. This is a quadratic equation and can be solved by factorization. So x square minus 3x minus x plus 3 equal to 0, and taking x common from first two term, we will have x minus 3, and taking minus 1 common, we will have x minus 3 equal to 0. So we have x minus 3 times x minus 1 equal to 0. So we have two factors, x minus 1 equal to 0 and other one is x minus 3 equal to 0. In this case, x equal to 1, which is the stationary point, and x is equal to 3. We have the x coordinate of two stationary points. First stationary point already given in part 1, which is this one, 1 comma 9. We need another stationary point, so we will use the x coordinate of other stationary point. Now plugging this stationary point in equation of curve, we can find y coordinate. So equation of curve is y is equal to x cube plus ax square plus bx plus 5. And we know that a is -6 and b is 9. So plugging these values, we will have y coordinate. So y is equal to x cube means 3 cube plus a means -6 times 3 square plus 9 times 3 plus 5. Okay, further solving, we will have y is equal to 27 minus 54 plus 27 plus 5, and this one is equals to the y is equal to 5. So we have calculated the y coordinate of the stationary point. So we have stationary point 3 comma 5. Okay, part C, the point P is moving along the part of the curve in such a way that the y coordinate of P increasing at the constant rate of 6 unit per second. So it is given that dy over dt is 6 unit per second. Okay. Find the rate at which x coordinate of P is increasing when x is equal to 5. So we need to find the rate of change of x. So dx over dt at x is equal to 5. We already have dy over dx, which was 3x square minus 12x plus 9. And it is given that dy over dt is 6. So we can use chain rule to find the dx over dt. So by using chain rule, we have dy over dt is equals to the dy over dx times dx over dt. Now plugging the values of dy over dt and dy over dx in this equation, we will have dy over dt is 6. 6 is equals to dy over dx, which is 3x square minus 12x plus 9 times dx over dt. We need to find dx over dt. So dx over dt is equals to the 6 over 3x square minus 12x plus 9. So we have calculated the rate of change of x with respect to time, and we need to find rate of change of x with respect to time at x is equal to 5. So dx over dt at x is equal to 5 is equals to the 6 over 3 times 5 square minus 12 times 5 plus 9. Solving this, we will have 6 over 75 minus 60 plus 9. So solving further, we will have 6 over 24, and this one is equals to 1 over 4. We can say that the x over dt rate of change of x with respect to time at x is equal to 5 is 0.25 or 1 over 4. This was required.